Hi everyone! Today we're going to take a look at scale drawings, and this is going to come in handy later at the end of our unit when you turn in a scaled drawing of your inclined plane that you create for me. So let's start out with the definition. What is a scale? A scale is simply a ratio, and a ratio, if you remember, is simply a fraction. So we write scales with colons typically, so we could have a scale, let's say, that is a 1 to 12 ratio. And this is the same as saying, in fraction form, a 1 to 12 ratio again. In this case, in the colon case, the colon corresponds to 2, as well as the division symbol, or the fraction symbol, corresponds to 2 when we say what a scale is. So now that we know what a scale is, let's use a scale. So now we have this tree. We'll say that this tree is approximately 120 inches tall. And typically, a piece of printer paper, or even a piece of paper in your notebook, one paper is approximately, that's the approximately sign, 12 inches long, or tall in this case, 12 inches tall. How many pieces of paper would it take to draw a life-sized tree that is 120 inches tall on paper, on several pieces of paper? How many pieces of paper would it take to draw that life-sized tree? Well, we can do that, and we can do that with ratios. So we have 120 inches of a tree to put on several pieces of paper that are 12 inches long or tall. So in this case, we're saying that you can only put 12 inches of that tree per piece of paper. And we create this nice fraction, and all we have to do is reduce. So if you want to use your calculator, you can plug in 120 divided by 12, and you'll find that we indeed need 10 pieces of paper to draw a life-size tree that is 120 inches tall. But when are you going to ever need to draw a life-size tree on paper? Probably never. So this is all about applications. So we would ask you to draw a life-size tree on one piece of paper. So let's do that. And in this case, we'll make a scale. That's where scales help tremendously. So in this case, we'll say that for every 1 inch, at this point you should recognize that the number on the left of the colon corresponds to the dimension of the drawing, while the number on the right of the colon corresponds to the dimensions in real life. And I'll just write that down real quick for you guys so that you'll remember real life and drawing. So if we say that for every 1 inch of our drawing stands for 12 inches of our actual tree, and don't forget that our tree is 120 inches tall, how many inches tall will the tree be on our piece of paper? Here we'll use our scale that we've already created. So we'll write it as a fraction, a 1 to 12 ratio. Every 1 inch corresponds to 12 inches in real life, and we will say we want it to correspond to our 120 inch tree. Now notice that the two denominators both are real life values. The 12 for the 12 inches and the 120 for the 120 inch tall height of the tree. So we're just going to put a little variable up here, and we're going to solve for the variable in our ratios. So to solve for our variable, we will just cross multiply, which is something you guys have been doing for a while. So if we cross multiply, we'll see that 12 times x is simply 12x, which is equal to 1 times 120, which is simply 120. And don't forget that what you do to one side of the equation, you have to do to the other side. And we'll find that x equals 120 divided by 12, which we saw earlier is simply 10. It would take 10 inches of your 12-inch piece of paper to draw that tree. And that is how you use scales to create a scaled drawing to fit a larger object in real life onto a smaller piece of paper. I'll see you guys next time.